Welcome, everyone. I'm Mr. Lineberger, and there's hardly anything that makes me happier than playing ukulele, especially if I get to make some music with my friends. It's satisfying, especially when it all comes together. Sometimes we start a new song and we're not sure whether we should strum fast or slow or finger pick it or shred some solo runs. And the first few times through, the new song might sound pretty rough. But when it all comes together, it's the best feeling. And here's something that might sound crazy, but it's those songs that sound the roughest that feel the best when they come together. You might be surprised, but I was heavily into skateboarding when I was in my teens and 20s. Same situation. The tricks that were the hardest, the ones that I really had to work for, those felt the best when I finally landed them. When I'm working on a complicated math problem, I get some of that same satisfaction, especially if it has a lot of steps that take effort and persistence, but that finally come together. Solving a long math problem can be really satisfying in the same way as making music or skateboarding. Today, we're going to learn a method to solve division problems. We're going to learn to divide 2- and 3-digit numbers by a single-digit number. And while it might look like there are a lot of steps, that just means it's going to feel that much more satisfying when you get to the answer. And now, let's learn about the partial quotient strategy. Let's learn how this strategy works. You start by writing down your dividend and placing it under a table. No, not an actual table. That's what people usually call it. If our dividend is 150, then we start by writing down 150 and putting it under a table like so. For our sample problem here, let's do something easy and use a divisor of 5. We write the divisor to the left of the table. The next step is to do a little mental math. What's a number that we could use to multiply by 5 that would give us an answer less than 150? This needs to be a number that we can multiply in our heads. Let's just use 10. 5 times 10 is 50. So I write 50 below the dividend and draw a vertical line extending our table. Then I write 10 over here to the right side to help me remember the number I used. I've covered 50, so when I subtract, that leaves me with 100 to go. What can I multiply by 5 to get 100 or less? I'll just use 10 again. That's easy and a safe bet. 5 times 10 is 50. I write 50 here, 10 here, subtract, and I have 50 left in my problem. 5 times 10 is 50. So I write 10 to the right of the table and I'm done. Now to get my quotient, I just add up the numbers on the right side of the table. 10 plus 10 plus 10. That's 30. The answer to my problem, which I write on top of the table, is 30. Now, let's use some real examples to practice the partial quotient strategy. My band had 50 shirts printed, and 3 of us agreed to sell the shirts. I need to divide my pile of 50 shirts into 3 groups so it can be responsible for selling an equal number. In my equation, 50 divided by 3, 50 is the dividend, and 3 is the divisor. I can also write it like this as a partial quotient problem. I put 50, the dividend, under the table, and the divisor, 3, on the left side. Then I draw a line straight down. To help me visualize this particular problem, I'm going to add 3 stick figures representing 3 members of the band. The first question I ask myself is, how many times can 3 safely go into 50? Or, what do I know for certain I can multiply by my divisor? In this case, why not start with 10? That's an easy number to do in my head. 10 times 3 is 30. That's less than 50, so it's fine. I'll add 10 shirts to each person. I'm distributing 30 shirts total. If I subtract 30 from 50, I get 20, which is the number of shirts left to give out. 7 would be too many to multiply by 3, since that equals 21. So let's go with 6. 6 times 3 is 18. 18 subtracted from 20 is 2. I've now given 6 shirts to each person, and there are 2 left over. How many total shirts will each person have to sell? 10 plus 6. Each of the 3 band members will need to sell 16 shirts. And we've got 2 shirts left over. In math, we call that the remainder, because it's what's still remaining. Get it? The answer to this problem, the quotient, is 16. Let's look at another problem. We had 75 posters printed for an upcoming show. Again, 3 of us are planning to put up the posters. How many posters will each person get? This time, I'm not going to draw my 3 people. Instead, I'm going to write those numbers to the right side of my partial quotient diagram. My dividend is 75, and my divisor is 3. Let's start with a safe guess. I know 10 times 3 is 30. That means 20 times 3 is 60. Let's start there. I'll write 20 on the side and 60 beneath 75. When I subtract 60 from 75, I have 15 left. How many times will 3 go into 15? That's one of my regular multiplication facts. 3 times 5 is 15. I'll write 5 to the side. When I add 20 and 5, I get 25. So, each of us will need to put up 25 posters. Are you ready? Let's take this to the next level. 7 members of my band got together to play a show outside at an awesome outdoor market. As people walked around and shopped, they would drop tips in our tip jar. At the end of the market, we had $112 in our tip jar. So, how much did each band member get to take home? We can figure that out. We'll use the partial quotient strategy to do it. I'm going to put 112 under my table and 7 on the left side. I'm not sure how many times 7 goes into 112, but I do know that 7 times 10 is 70. I'll write 10 on the side, then subtract 70 from 112. Okay, I know it's 30 to get to 100, and then 12 more to get to 112. So 30 plus 12, that's 42. I did that subtraction in my head. I'll write 42 down here. What can I multiply by 7 to get to 42? That's another one of my multiplication facts. 7 times 6 is 42. So 10 plus 6 is 16, which is the answer. Each of us would get $16. Just to make sure you know this strategy, imagine if we had made $543 in tips. Well, that would have been a sweet payday. But I could figure out how to split it using the partial quotient strategy. 543 goes under the table. It's my dividend. 7 is my divisor. I know that 7 times 10 is 70, so 7 times 20 would be 140. 7 times 30 would be 210. 7 times 40 is 280. 7 times 50 would be 350. 7 times 60 is 420. 7 times 70 is 490. 7 times 8 would be 560, which is too much, but pretty close. So if I needed to make a quick guess, I'd guess that the answer is between 70 and 80, but closer to 80. 7 times 70 is 490. I'll write 490 here and 70 here. 490 plus 10 is 500, plus 43 is 543. So I'll write 53, that's 10 plus 43, down here. What do I need to multiply by 7 to get 53? 7 times 7 is 49, so 7 goes on the right side, 49 goes here, and when I subtract, I have 4 left over. Looks like we'd each make $77, and there would be $4 left over. Today, we learned a useful strategy for division, the partial quotient strategy. We used it to divide a 2-digit number by a single-digit number, and we also used it to tackle a 3-digit dividend as well. Sometimes it will take extra steps, but extra steps are okay. That just makes the problem more satisfying when you've solved it. And as happy as I am talking about partial quotients, it's even more fun when you're rocking out on a ukulele.